So hopefully that's recording. All right, and again, this is something that kids always confuse. There's difference between a definition and Mr. Gill's most important rule. And kids really get this confused. What did Mr. Gill's definition, or what did I say an equation was? Definition of an equation for that response. So we did this bell work. You should all have it. Remember, if I put it on bell work, especially, I think I had that on bell work 2 days in a row. Let's see. Yeah, had it on there 2 days in a row. Oh, I don't have it on person. So what is an equation? I said, and then I did a
equation is just a rule.
It says what?
That says the equal sign separates the left from the right.
Well, so equal sign separates the left and the right, but what's true about the left side and the right side? The value on the left has got to equal the value on the right. What that means, in equation, I don't care what's on the left. 3x subtract 8 equals 10. 4 times 7x plus 1/2 equals 40. I don't care what it looks like on the left or on the right. Could have a like weird stuff on both sides. We will eventually. They're just numbers. This is a number. Now, we don't know how to get this final number because we don't know what that number is. We don't know one of the numbers in there. We can't figure out what the final number is, but it's just a number. And that number, whatever number this is, this unknown times 3, because remember, you better know immediately what that means. What's 3x mean? What does it mean? X is not multiplication. 3 times x. If you haven't committed that to memory yet, you better write it every time I say it, every time you have to do it, every problem you have that has a number next to a variable. I don't know how you're going to pass this class if you don't immediately know that. It comes up in everything we do, really all year long, but definitely all quarter and all semester long. We do stuff with equations. I mean, that's pretty much what algebra is. Solving for an unknown variable. Or creating an equation. This then is what? 7x is what? 7x, 7 times x. When I say, I'm not asking you to give me the answer of what 7 times x is. You don't know x, so you can't do that. I'm just trying to make sure you understand 3x means 3 times x. Any number next to a variable means that number times that variable. So if I know this is multiplication, then I could figure out what number, and this would be one that would probably be a fraction. Actually, it wouldn't be a fraction. What number is x? Figure it out. Use paper. If you can do it in your head, figure it out. The top one, bottom one's way more complicated. What would x have to be if this side has to equal that side? What do you think? Well, this whole term would have to be 18 because 18 subtract 8 is 10. But what would x have to be? So this whole thing is 18. So now you got to figure out, okay, if that whole thing is 18, what would x have to be? 6, right? Because 6, because if this is 3 times x, 6 times 3 is 18. So that's really all you're doing is you're just figuring out what number does x have to be to make this side, the left side, and again, the sides are always separated by where the equal sign is. Doesn't matter how much stuff's on the left. So 6 times 3 is 18. 18 subtract 8 is 10. So again, that's why we can solve for a variable if there's only one variable, because we have to follow the rule. The equation is a rule. And the only number that will make that rule true, that the value over here is equal to the value over there, there's only one number, 6. No other number will work. You can try any number in the world you want, won't work. So we said a rule is value of the left equals the value of the right. Okay, so that's one you need to commit to memory. You need to understand, well, not memory. Hopefully you understand that an equation just means, okay, both sides are really just numbers. I may not know what those final numbers are, but whatever that final number is, it's got to be equal. And that's what we use, that concept is what we use to be able to solve. What is that in the upper right, that PEMDAS? Why do I have that up there? What do you think? It is the order of operations. So what's it stand for? And we did this the other day. Parentheses, exponents. Why do I have MD underlined and AS underlined? Well, it doesn't always happen, but that's not why they're underlined. Let's give you an example. So, and this actually isn't a good example. So in that problem, if I strictly followed the order and I went parentheses, exponents, then I went to multiplication, I would skip over this and I would do that first. That's not how we do it. When we get to multiplication, we treat multiplication and division as kind of like equal. So we just go left to right, and if division is first, then we do division. If multiplication is first, then we do multiplication. So they're kind of together. These are also kind of together. We don't skip over subtraction to do addition. We do either addition or subtraction if we get to it first. So kind of the same thing here. We do either multiplication or division, whichever one comes first when we go left to right. So we don't practice a lot of that. I do in another class. That's not an algebra standard. That's a pre-algebra, really before pre-algebra even. So, but you need to understand order is that PE and then multiplication or division, depending on which one comes first, and then finally addition or subtraction, again, whichever one comes first. What else? What else? Oh, so we did that one the other day. I'm kind of just reviewing the stuff we did 2 days ago. We solved out. All right, so now let's go ahead and do this one. Yeah, let's do this. So negative, this is probably one on one of your papers somewhere. Actually, tell you what, I'm going to do a more difficult one for you guys. I'm just going to make one up. So this is not on your papers, but we'll go through all the different steps. All right, so there's a two-step equation. This is what you need to be able to do on Monday. Yeah, I'd be taking notes on this one. I'm going to go through everything that you need to know. This is about as difficult a problem as you'll see on Monday. I don't really feel like I can, I mean, I guess I could put a negative also on the 8 maybe. So the first thing that you may look at there and think, oh, I don't like that problem. What's the little unique about that problem, or little different? There's some negatives in it, but you're going to have some negatives. I wouldn't say that's super unique. What is also kind of different the way we see a problem alive? I go with Kennedy on this. It's tires. What's that? What about it? So typically we've seen a problem where this one single number is on the right. And we call it an expression, but the expression that has two terms in it is on the left. So that's a little different. I'll talk about how we can handle that. What else is a little different than certainly the first few problems we did? Anybody else see something that doesn't quite feel right to them? What about the order of the 8 and the 9y? Is there anything different about that? Because there is. Typically, when we started out, and we may have done some of these already, but we normally were seeing something more like that. The term with the variable was on the left, and then the number was on the right on this side. So they were all on the, so this was on the left, this was on the right, but also those two terms were typically flipped. We normally had the term with the variable first. And you sometimes, students sometimes, get in the habit of knowing, oh, well, I always am going to start with this number over here, the number on the right. It doesn't matter right or left. You can't think I always start on the right. I always start on the left, because I can always switch the order of the numbers or the terms. You have to start where? What is the rule? I mean, I guess kind of is a rule, but it's what you need to be thinking to yourself when you first start a two-step equation. The way we know this is two steps, by the way, I only have one term with a variable in it. That's the only term with a variable. There's no more variables on this side. There's no variables on that side, but I do still have two numbers. So only one term with a variable and two numbers. That's how you know it's two steps. So when I say a two-step equation, that's how you know it's two steps. Only one term with a variable and two numbers. So what do we start with? What's our goal? Let's go backwards. I'll call on you in a second. What's our goal? Goal is always this. Even if it looks weird and it's flipped in different sides, our goal is still the same. What's the goal? Get the variable by itself. Always. Doesn't matter what an equation looks like. If you are solving for a variable, that's the definition of solving. Get the variable by itself. You really, really come to understand that and then understand how to do that. You especially using that most important rule that we'll talk about in a second. You should be pretty good. So if we're going to get it by itself, what do we have to get rid of? We're doing the top one up there. What do we have to get rid of to get that y by itself? And so we got to get rid of the 8. And what kind of 9 is that, though? -9. Remember, the next thing we said, a sign or whatever the sign is in front of a number is glued to that number. So if you think of that as subtraction, that's fine. But regardless, that sign is glued to that 9. Whatever we do with that 9, we're going to use that negative sign. What's the math going on between that -9 and that y? Said it a second ago. What's going on between the -9 and the y? We're multiplying them. Again, if you didn't immediately know what I was talking about, you need to write it down again. That'll be the second time you should have written it today. This is -9. I'll rewrite it. That is -9 times y. You've got to understand what the math is that's in the original problem, because the way we solve is we do opposite math. If you don't know the math going on in the original problem, how are you going to remember what math to do to solve? Because it's not always going to be an easy problem. Sometimes you're going to have to kind of figure pieces out that don't fit our normal process. Now we can change the sides if we want. Like I saw kids doing this yesterday, so I'm going to go ahead and go over it. I didn't put this in the lesson yesterday. If I really, really am more comfortable putting this stuff on the left and this number on the right, you can always do that. Because remember, the sides are equal. If you remember my example, 10 plus 5 equals, well, I'm not going to write the dollar signs. I'm not even writing the plus signs, but if I have a $10 bill and a $5 bill on the left, and I have all that on the right, 2 5s and 5 1s, it was equal, we said. Well, isn't it still equal if I take all of this and I put it on the left and I take that and I move it to the right? It doesn't change the value of either side. If the value was equal originally, I can flip the sides and the value is still the same. So I can change this and move it over here and take this and move it over there. Still be equal. They were equal originally, they'll still be equal. But you got to be a little careful, especially with subtraction. So here's what I see a lot of kids do. And if you're not getting all this written down, remember it's recorded. Some of you will just understand that you can't do this, but some of you will make this mistake. A lot of kids do this. I'm going to take out the multiplication symbol, but still, they do that. And they're like, yeah, I want to flip it around. I want to put it in a way that looks more familiar to me. So they flip it and make it 9y subtract 8. What's wrong with that? Daniel, what did I do wrong there? No, you don't need the multiplication sign. I was just kind of showing it to you. What do you think? I can put it in front of there, but I'm kind of messed up when I put it in front of there. What did I do wrong when I did that? Go to.
Oh, it's a basic rule in subtraction that you're not supposed to take your number.
Nope, nope, nothing to do with that. I can put the bigger number, smaller number, it doesn't matter. What did I just say about the negative in front of the 9? It is glued to that 9. If you didn't catch that, you need to make a note. Because that's, even if you don't flip the order, that's still going to happen a lot where you need to make sure you keep that negative sign or subtraction or whatever you want to call it. You have to keep it. This is a positive 8, right? There's nothing in front of it, so that means it's positive. So when I rewrite it, that still needs to be a positive 8. It still needs to be a negative 9. That is correct. So again, if you decide you want to flip the sides, either you need to write it exactly like it is, so don't change the order at all. Like you could have just written positive 8 subtract 9y. So don't change anything except for the sides. Or if you're going to try to flip everything, you need to look back to the original sign that's in front of each term and make sure it's the same sign once you've flipped it. So just be careful. I'm not going to tell you not to do it. I'm not going to tell you to do it. It's up to you, but you've got to make sure the signs match up. Positive 8, negative 9y, negative 9y. It really doesn't matter which version, so you don't really need to switch it. I'm still going to solve from the original one up here and show you that it doesn't really matter which one we use. And if you're comfortable just leaving it the way it is, then that would save you from maybe making a mistake trying to flip it. So again, let's start with this. I'm going to solve for y, which means we're going to get y by itself. Getting y by itself means we need to get rid of the 8 and get rid of the negative 9. I never do anything to this first. I don't care what's over here. Eventually, I'll have to do something because what's my number 1 rule? When I'm solving, what's the number 1 rule? Not a definition, but the number 1 rule. This is if you follow this, you really can't go wrong.
Get rid of the numbers with the.
That's where we start. But what's my number 1 rule? Just is we go through the whole process. This is the rule for the whole process, not just the first step.
They both have to.
Well, that's the definition of an equation. They both have, but when I'm solving, what do I need to make sure I do?
Whatever you do.
Yes. There you go. You both said it at the same time. Now, when I'm actually solving, whatever I do to one side, I've got to make sure I do the exact same thing. I'll tell you the next mistake some people make. Sometimes they'll get the first. So where do I start? Say it again. Do you remember where we started?
Oh,
Said it, or that was, I think, the first thing you said. How do we know where we
get
start?
rid of the number.
Well, so you're saying we start with this, negative 9? You want to get rid of negative 9? Because we're going to get rid of the negative 9 and the 8. Because we got to get y all
So
by
you
itself.
Start with the 8.
Yeah, we never start with the term that has the variable. So we never start where the variable is. And we never divide first. There's really, you may multiply first sometimes. You really, I mean, I can't think of any examples where your first step is going to be at any level. Like, I don't care how complex it is. I'm not saying you, I mean, I could create a problem like that if I really thought about it. But in general, there's no problem you're ever going to get where you start by dividing. So we wouldn't try to get rid of this negative 9 by dividing first. Never going to start with division, which means our first step is to get rid of that 8. How do we get rid of an 8? Well, that's what some people do. Just erase it. And it's sort of like just erasing it. What's the equivalent math-wise of just erasing it? Just getting rid of it. I'm taking it away if I erase it. So what's taking away mean?
Sure.
In this case, I'm subtracting. Why do I say in this case I'm subtracting? Because I won't always subtract first. Why am I subtracting in this? Because we think opposite, right? Remember, when you're going through and solving, you're thinking opposite math. Opposite math. Well, the opposite math of because basically what I'm doing to this right side is I'm adding an 8 and I'm subtracting 9y. So if I'm adding 8 to this side originally, I need to say subtract 8 to get rid of that. I do opposite math. So that's another one you gotta have ingrained in your head, memorized. You know, again, whatever I do to one side, I do to the other. And in the process of doing that stuff, I need to be thinking that I'm doing opposite math to get rid of stuff, to get that variable by itself. So what's my number one rule again? What do I need to do? If I subtracted 8 on the right, I gotta subtract 8 on the left. So negative 50 subtract 8 is like being in debt $50. You owe $50. That means you're negative 50.
42.
And then also note, because I'm subtracting more from it. Net subtracting 8 is like giving you a bill and saying you owe $8 more. And you already owe 50, so now you're more in debt. So that means if I'm more in debt, I'm actually negative 58. If I gave you $8, you could pay some of your debt off and you'd only be in debt $42. So again, we'll do a bunch of examples where I talk about money. You'll start to catch on to that and be able to do it a lot faster. But for now, I'm more worried about you doing the right steps than the right math. You can still get a 3, a B by doing the right steps. You would have to get all the math right to get an A on it. So if you're concerned about that, you can practice doing that on your own today. What's on the right-hand side? Oh, I'm going to call on somebody for this. Ray, what's on the right-hand side? So 9y. We didn't do anything with the 9y, right? What did I just say? Whatever's in front of the 9 is glued to the 9. Do not bring that 9 anywhere. Do not do any math with that 9 without that negative sign. They are glued together. You need to write that note if you keep doing that mistake and it doesn't automatically happen for you. You need to say, this is glued to this 9. Now, what's the math going on? I already called Kitana. What's the math going on between this negative 9 and that line? So if it's multiplication in the problem, what would the opposite of that be? That's why I divide as my last step. And normally at the end, you will get to something where you have a number times a variable. That's the normal last part of the problem. That's what the problem looks like at the end. That's why normally our last step is division, because this is the way it's going to look at the end. So I divide by negative, and again, should have made you guys do that part. That negative sign is glued to that 9. So if I'm going to divide by the 9, I better be bringing that negative sign with it. My number one rule, whatever I do on one side, I have to do on the other side. You will get, although on your worksheet, you actually don't get any decimals. On my quizzes, you will get decimals. You will get fractions. You don't have to change it though. So the final answer is really just this. Wait, what's the rule for a negative divided by a negative? Negative divided by a positive is negative. Positive divided by a negative is negative. Negative divided by a negative is positive. So I wrote the rules. If you want to jot them down on your paper. So that becomes a positive 58 over 9. There's nothing you can do with that. 58 over 9 is as simplified as it gets. You can't make it smaller numbers and still have it equal 58 over 9. Because it's not divisible by, this is not divisible by 9, and it's also not divisible by 3. So there's no number you can use to simplify. If you don't know what I was just talking about, again, I'm not super worried about the math today or for Monday. If you're really worried about getting a 4, then you do need to know what I'm talking about. But I probably won't give you any that you even need to simplify, so you shouldn't have to worry about that for the first quiz. So that's a little bit of review. Well, I guess a lot of review. We did all of that last week. So you can go ahead, I'll walk around, you can work together. If you know somebody, you're not sitting next to them, I don't care if you move around to work together. If you're not working, then I will put you back where you were. But remember, you take the quiz on Monday, not that person you're working for. So they're doing all the work and you're just writing answers down. That's not gonna help you much on Monday. I don't think this is a super difficult quiz on Monday. If you practice. Sit there and you don't really practice much, then yeah, it's gonna be tough. This lesson is all about practice. The more problems you do, the more you start to just automatically know where you start, what math you need to do to solve to get the variable by itself. But you've got to put some time in today, and you got a bunch of it. You got over an hour. I'm going to stop the recording because there's going to be a bunch of dead time, even if I do another problem, even if I do fractions. I'm not going to leave it running for the whole time. I can always add, we can do a quick review on fractions next week and I'll record that one. So I'll post this. If you